Namaste student. Here we have periodic evolution for class 10. So you can see the question. So push the video, get the screenshot, take your time, solve the question problem, and then again come back and you can see the explanation of it, or you can go directly explanation. Okay, so here we have 9 problems. You can see. Okay, here we have explanation. The first one. So here you can see that first problem, after how many decimal place will the decimal expansion of 43 by 2 to the power 5 into 5 to the power 3 terminate? Look at here, denominator is already in the form of 2 to the power m and 5 to the power n, for m and n belongs to natural number. So now you see the power and look at which one is the highest one. So here you can see the larger part is 5. So you can say that this one will terminate after 5th decimal place. Okay. Next one. Are the square root of all non-negative integer irrational? If not, give example. Okay. No. You can see that no, square root of all integers are not irrational number. For example, if we'll take root over 4, you can see that it will give you 2 and 2 is a rational number. So square root of any non-negative integer may or may not be what? Irrational. So second answer is no. The next third one is 4 into 7 into 9 plus 7 is a composite number. Justify your answer. Now you can see the process what we have done here. You can see 4 into the 7 is there, so we are taking common 7 and you are getting this one. That means 7 into 37, 7 is a prime, 37 is also a prime. That means this number, this expression can be expressed as product of prime, and we know that by fundamental theorem of arithmetic every composite number can be expressed as a product of prime. So this expression is a composite number. Okay. Next, given that root 3 is an irrational number, prove that 3 plus root 3 is an irrational number. So here we have two methods. So we'll see both the method. So you can see that already we have discussed this method. So by contradiction method you can see this one already we have seen. Okay, the next one we'll see alternative method, we'll see for the fourth one. So we are taking this one as, again this one is also a contradiction method, another way. So let 3 plus root 3 be a rational number, and we know that addition of two rational number is rational. So we have assumed that this one is rational and minus 3 is also a rational. That means if we'll add these two rational number, will give you a rational number. So you can see that plus 3 minus 3 cancel each other, and you are getting here root 3 is a rational number. But according to question, it has given that root 3 is an irrational number. This contradicts our assumption. Hence 3 plus root 3 is an irrational number. Next problem, question number 5. Using prime factorization method, find the HCF and LCM of 12, 16 and 24. I hope that you know how to solve it. We have already discussed this type of problem in our classes. So you can see here, this is your method. So you just make it in a prime factorization form. For HCF, take if the number is common, then you take the lowest power number. So you can see that 2 is common, so we are taking the lowest power one. So here is our answer. And for LCM, we'll take the highest common number. So here you can see that there's a common number, so we'll take the highest one. So here highest one is 2 to the power 4, and if there is no common also, we'll take the number which are not common. So here 3 is not a common, so we'll take highest one. So you can see that there's a 1 and there's a 1, so we'll take any one of them. So here 3, and your answer is 48. Okay, next problem, question number 6. Okay, we'll see this one, how to solve this part. We'll see this part, 6 number. See here what they are saying. Show that one and only one number n plus 2 n plus 4 is divisible by 3. So here they are saying any number will take. So let's take, okay, I forget to write here, n belongs to any positive integer. Okay, so let's take, we know that this is divisible by 3, so we'll take the number as, let a be any positive integer and b equals to 3. Then what? Then by Euclid division lemma, a can be written as 3q plus r, where q belongs to natural number and r equals to 0, 1, 2. So this implies a equals to 3q when r equals to 0, a equals to 3q plus 1 when r equals to 1, a equals to 3q plus 2 when r equals to 2. Now you can see that what they are asking, that n is any natural number. So we need to see that case three cases are there. We need to see that which are supporting which one. Okay, so let's say case 1, when n equals to a equals to 3q. You can see that n equals to 3q is divisible by 3. Case 2, when n equals to 3q plus 1. Okay, that means you can see that n equals to 3q, if we'll choose, is not divisible by 3. So why sir? Because there is a remainder. Okay, so we'll not choose this part. Directly you can see that n plus 2, that means not n plus 2. Which one we have? N plus, we'll choose, okay, n plus 2 we'll choose. Okay, correct. 3q plus 1 plus 2. You can see that 3q, and this will give you 3, which can be written as 3q plus 1. And look at here, 3 into q plus 1, it is a multiple of 3. That means if you take any 3 and you can divide it, this means this is divisible by 3. So case number 3rd. So what you can see, when n equals to 3q plus 2, n plus 4, that can be written as 3q plus 2 plus 4. And look at here, 3q plus 6. Here you can take common 3, q plus 2, and look at here, 3 into q plus 2, and this is integer and this is another integer, and multiple of integer will give integer. And look at here, it is a multiple of 3, that means is divisible by 3. Therefore only one of the number n, n plus 2 or n plus 4 is divisible by 3. Okay, so you can see this one. So next problem will proceed. So here we have seventh one. So look at here, the seventh one, what they are saying. Show that 12 to the power n cannot end with the digit 0 for any natural number n. So already we have done this type of problem. So here you can see 12 can be written as 2 to the power 2n into 3 to the power n. Here you can see that the only prime factorization of 12 to the power n are what? 2 and 3. You can see not the 5. And also by fundamental theorem of arithmetic, this expression is unique. That means we'll never get any 5. And to get unit digit 0, you need two factor common, that is 2 and 5 must be there. Then only 2 into 5 will give you 10 and this will be your 0. Remember. So here we have 2 but we don't have a single 10. So look at here, there is no, not single 10, 5. We don't have any 5. That means we'll never get 0 at the end, or in unit digit we'll never get 0. Okay. So here question number 8, you can see, prove that root 3 plus root 5 whole square is an irrational number. Same contradiction method will apply here. You can see this one. Here we have already discussed. You can see this one. Okay. Next, question number 9. So last question, you can see, if D is the HCF of 45 and 27, find x and y satisfying D equals to this one. Okay, our target is that to get the HCF in the form of this, and this is your linear expression. We call this is the linear expression of x and y. Okay, so first our target to get D by Euclid division lemma. So here we have already we have this part. So our HCF, this means this is your D, so this one is your HCF. Now to get your linear expression, your target is that 27 and 45. Okay, so what we're going to do this type of problem, skipping the last stage, you can see that remainder is 0. We'll not choose this part. We'll take this two equation, say this one as first and this one is your second. So D means 9. That means here you have D equals to 9. So look at here, from second equation 9, that means D, this is your D, 9, that is D, can be written as how? 27 minus 18 into 1. Now look at here, always try to take the remainder and replace this one. First case we have taken this one, we are writing 9 as 27 minus 18. Next target this one, this remainder. Look at the remainder 18, that means from 1. Okay, what you can write, 18 can be written as 45 minus 27 into 1. So look at here, this is your 18. Now you replace in the place of 18 with this expression. That means minus 18 can be written as 45 minus 27 into 1, and outside 1. From where you have got? From 1. Okay, now 27 minus, so 41 into 45, sorry, 45 into 1 will give you 45 into 1, and 27 into 1 will give you, see here, minus minus will give you plus. This one minus plus minus 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 plus 27 into 1. So here how many 27 you are getting? 227. Have you seen? So you can write 27 into 2, and this one can be written as 45 into 1, but our target is plus. Okay, so we can write this one as 27 into 2 plus 45 into minus 1, and demand is what you can see here, 27 into x plus 45 into y. And look at this one, therefore we can compare what we can compare here, 27 into x, and x is what, 2, therefore x equals to 2 and the y equals to minus. Remember, in this type of problem we will always get opposite symbol number. One may be positive, another may be negative. Both can't be negative, both can't be positive. Okay, thank you.